What up, friends? We're talking about classful addressing. Now, what is classful addressing? Okay, you probably ran across this in the text, all right, where you saw some IP addresses that were labeled Class A, B, or C IP addresses. When we're talking about classful addressing, we are talking about public IP addresses. These are the IP addresses that are assigned, available publicly, the 4 billion plus or minus IP addresses that are available in the IP version 4 space, right? They're assigned, they're public. Okay, this is what we're talking about. Up until this point, in this video series, we have been using just a regular 10 dot internal IP addressing scheme. Okay, so I guess technically you could say that's a Class A address, but it doesn't really mean anything because it's an internal IP address. Classful addresses only matter when you're talking about public IP addresses. Okay? Now, what is a public IP address? Well, when you sign up for cable with Spectrum or Comcast or whoever's your cable provider, and they give you a single public IP address, right? And that's the IP address for your router. That is a public IP address. And then what you do is you hook up your Wi-Fi to it, and then your Wi-Fi assigns IP addresses to all the devices that connect to it, and those are internal IP addresses. So that's the difference between an internal IP and a public IP. And that scales up for businesses. So, a business can have one public IP address. It's usually more than one, but they, can have one public IP address for an office building that has 500 people working in it with 2,000 devices. And all of those IPs are assigned inside the building are assigned internal IP addresses. And all of that traffic on all those IP addresses is just pumped through that single public IP address, or and oftentimes it's just one or two or three or four. It's usually not just one, but you get my point. You have thousands of devices, thousands of IP addresses, all pumped through one or two public IP addresses. And that's what we're talking about when we're talking about the difference between a public and a private IP address. And again, classful addressing is for public IPs only. Public IPs only. And you can determine the class of a public IP address by just looking at the first octet. It's that simple. Look at the first octet. Class A ranges from 1 to 127. Class B ranges from 128 to 191. And Class C ranges from 192 to 223. Now, for these public IPs, there you have a default subnet mask. So, and there they are right there. For a Class C address, the default is 255.255.255.0. And for a B, 255.255.0.0. And for a Class A, it's 255.0.0.0. And again, same, the default CIDR. The CIDR and the subnet mask, they convert from decimal to binary. So look at 255. So what is 255 in binary? It's 1111, 1111. You have 8 ones, so the default CIDR is /8. Works the same for Class B and Class C. So let's answer these questions. What is the network portion of a Class A IP address? Well, how do you determine the network portion of an IP address? Well, you look at this subnet mask right here, and you look at the number of ones, right? So there are 8 ones, the 8 ones. So only the first 8 digits in the IP address is going to be part of the network portion of that IP address. So what is it? If it's the first 8 binary digits, and it's going to be the first 8 binary digits of the IP address. So it's just what? It's just the first octet. It's that simple. It's that simple. So the network portion right here, it's just the first octet. For a Class B, what's the network portion of a Class B IP address? Look here. It's this octet and this octet. So it's the first 2 octets, of a Class B IP address. And for a Class C, the network portion is the first 3 octets. Now, let's look at this. I want you to look at these numbers. And think about the number of digits that we use to create subnets and the number of digits we have left over to create host. Think about that. So look at these numbers, right? We're using the first octet here to create what? Subnets. So we have 3 entire octets left over to assign to hosts. That's thousands and thousands of hosts. So we have very few subnets and tons of hosts, right? Thousands and thousands of hosts. Okay, let's move down here to class B, right? We're taking 2 octets to create subnets. That leaves us with 2 octets left to assign to host. Still lots of hosts, but less than class A. Now let's look at class C. We're taking 3 octets to create subnets. Thousands and thousands of subnets, right? And we're down to a single octet to create hosts. Well, it's precisely 256 hosts per subnet, right? So you move from as you take more binary digits to create subnets, you get fewer hosts per subnet, and it works in reverse. It works in reverse. The more hosts you have, the fewer binary digits you're going to have left over to create subnets. Creating hosts and creating subnets work in opposition to one another. So what answer did you come up with for these questions? What answer did you come up with? Well, we already answered them. So class A, first octet. Class B, first 2 octets. Class C, first 3 octets.